Hey everyone, in this project I'd like to show you a very modular automatic RAG system that I built with individual functions for text splitting, embedding, and all of that. It can actually automatically scrape given URLs. It can read text and PDF files. It chunks them, saves them to chunks.json file. It gets their embeddings and saves them to embeddings.json file. And when we perform search, it saves the top chunks into a JSON file. And we also get GPT-4 Omni to answer from these. I just wanted to make it as transparent and modular as possible. I have functions for every thing that you might need, like fetching from URLs from Gina, loading text and PDF files, counting tokens. So it's quite a lot here, including cosine similarity function. When you run this, it automatically looks into the data folder, and there is whatever text or PDF files there is, it automatically saves it to chunk.json file. I've set the chunking strategy to 800 tokens with 400 overlap because that's what OpenAI uses. So if we actually go to the beginning of the next chunk, we can see that it's halfway through. This chunk is actually present in the first chunk. After that point, we are able to enter URLs, as many URLs as you like, comma separated. I'm going to paste the URL for the analytical engine and also for the quantum physics Wikipedia page and just enter. First, I have to select URLs to actually scrape URLs, and then I will enter their URLs here, comma separated, and done. Now it should automatically retrieve the contents as text using Gina AI and save them. So now I can go into a search mode by typing search, and then I can enter queries. Here, let's look for some information from the analytical engine. Here it says from 1872, Henry continued diligently. Let's ask a question related to that. So let's ask, what did Henry continue in 1872? When we enter that, we can also enter the top chunk results. Let's select 5, and we print the tokens that are in the messages. And then it says in 1872, Henry continued diligently with his father's work, which is correct, as it was in the Wikipedia article. We also have the top chunks saved into top chunks text.json. So you can actually, use this to build systems and test it. Maybe the different query strategies. Maybe you can get GPT to generate multiple queries. I actually want to build a web research agent, but I wanted to first make this video due to the modular nature of this. You can actually use this to really customize and get it working exactly as you like. The code files for this will be available at my Patreon if you want to download them, and the link will be in the description. You can also specify the encoding models. I am using tick token and also the embedding model, text embeddings 3 large. Let's actually switch this to small. And let's run the script again, which will automatically embed this PDF file. We split it, chunk it, and embed it, turn it into a vector store. And it is this paper for Llama large language model. So see, I just wanted to show you also how you can experiment with it to try to find like the best strategies for retrieval augmented generation. If you were to ask, I'm immediately going to go to search because I'm not going to enter any URLs since we have already embedded the PDF file. I can ask who are the authors of the Lana paper, as they are at the very top. When I search and ask for 3 chunks, it says I don't know. I can ask this question again and ask for 10 chunks. And it still says I don't know, and I can ask it again with 20 chunks. And then now it actually properly lists it. So this was interesting. You see, it's definitely open to experimentation. Let's turn the embedding model from small to large, and let's run this again with the intention of asking same question. I'm going to type search and go into search and actually ask who are the authors of the Lana paper and ask for 3 chunks. We again it says that document do not contain. And let's try 5 chunks. And as you can see, when we use the large embedding model, it was able to answer it correctly, even just with top 5 chunks provided. However, with the small, it couldn't even answer it correctly with 10. and we had to go all the way to 20. So these are, some important things, I believe, and we will be reviewing the code, of course, shortly, but I just want to show you in the ways which you can use this. So like I said, to sum it up before we review the code, when you run the script, it will automatically split and vectorize all the files, text files and PDF files in the data folder. And you can also type in URLs and enter as many URLs as you like here, comma separated. They'll all be vectorized into a single DB, which in this case is a JSON file. And then you can actually do some experiments with it because this chat loop contains everything that takes place. So without further ado, let's review the code and see how it works. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x MasterClass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. The requirements for this project is TikToken, PyPDF, OpenAI, scikit-learn. We're using cosine similarity from scikit-learn, NumPy, and term color for colorful printing to the terminal. We import all our necessary libraries. Here we define our encoding model. I've chosen GPT-4, but there is other models available as well. An embedding model, I'm just going to leave it by default as large. And then we define an async OpenAI by grabbing the API key from environment variable so you can insert it here. Now we have our function, fetch text from URL, which just uses Gina AI. Gina AI just simply actually returns you the raw text, especially if you specify return format as text, just by placing this r.gina.ai in front of your URL. I have made an extensive video on Gina AI. It's this one here. You can find it on my website, echohive.live, or at the YouTube channel. It's one, Easy Web Scraping with Gina. You can also find the code download links if you're a patron. Okay, so this function just simply adds our URL and gets it scraped by your Gina AI and returns a response.txt file. Gina, you don't need an API key. You can just use this out of the box. You are more rate limited if you don't have an API key, but they give away API keys for free if you go to their website. And then our next function is to load a text file. Simply just read it and return its content. Load PDF file is going to use the PDF reader from PyPDF2 and read it page by page and append each page and return the final page. Since we're going to be chunking ourselves anyway, we have a function which can count tokens with tick tokens. So this should be useful. You can pass in any type of text and it'll return how many tokens there are. That's how I'm printing the length of the messages here in yellow, number of tokens in messages by stringifying the messages and passing it into count tokens. Then we have process text, which is going to get a tokenizer for the token encoding model, which we have specified at the top as GPT-4. And then it's going to encode a text, but then it's going to split the encoded text into 800 token chunks with 400 token overlap, initialize an empty list, define these variables, why 800 with 400 overlap. That's what OpenAI uses for their assistance API. I thought they might have picked this for a good reason, so that's what we're using, but you can actually change these to any amount you like. So that's why I think this is a great experiment. This script will be a great way for you to experiment with different chunk sizes, overlaps, or anything else for that matter. It's a simple function, and then it just appends all of them to a chunks list, and then it returns it. And those chunks are both written to chunk.json file, so you can also take a look at it for observability purposes. Then we have embed text chunks function, which is going to take a list of chunks. It's going to take the list of chunks and actually call OpenAI and then return. So it's going to take a chunks list and be defining another async function under it to take in a chunk and call the embeddings endpoint and return the text and the embedding of that chunk, since chunk is the text. And then We create tasks. That's how async.io works for chunk and chunks, and then we gather those with async.io, and then our embedded chunks are ready, so we can return them. And then we have a function, save chunks to file, to save the text of these into a JSON file. And then we have embed query, which is going to actually make another call to the embeddings. And actually, this is to embed the user query here. Since you have this function, you can either pass the user query directly into it, like I'm doing, or actually do some manipulation before passing it on, such as maybe perform any kind of manipulation. If you thought you can improve the performance of the RAG that way. Then we have a cosine similarity search, which is going to take the queries embeddings and the embedded chunks. It defaults to top K5, but we are asking it in the terminal anyway. Then going to turn everything into a NumPy array, and then perform cosine similarity over those embeddings. And then we're going to get the top K indices and return only the text of those indices after the cosine similarity search. Then we save top chunks text to file. We actually loop over the top chunks, which is what is returned from the cosine similarity search, and we save it to top chunks.text. This is again for observability purposes. So you can actually perform a search on the terminal, and your top chunks will be saved here. You can perform additional search here with Control F, just to see which chunks were retrieved, to see if you can actually improve the performance of it. And we have a call GPT-4 streaming in JSON. It is automatic. It doesn't. You can also turn on this JSON mode, but I am not using it. But you can. For example, you can actually call this function to return multiple queries, right, to perform cosine similarity with. But currently it's just designed to answer, but this is a pretty modular generic function using GPT-4o with streaming responses. It just returns assistant response in the end. And when we enter the chat loop, we initialize all chunks and embedded chunks empty folders. We assign the data folder as data, so you can put here as many PDF or text files as possible. We automatically check for all the text and PDF files, and then we extend the all chunks list with all those files contents, and then we save those chunks to file. We do call the process text over them. As you remember, process text was using tick token to split it. This is our text chunker, I suppose. I could have given it a better name, but there it is. And then we save those chunks to file, we print, and then we get the embedded chunks for all chunks using the embed text chunks function. And then we extend the embedded chunks as with the new embedded chunks, because this can work with multiple. You can add additional URLs and stuff, right? So that's why. And then we save the chunks to file embeddings.json. And now we print the information. Both chunks and the embeddings saved to embeddings.json. And then we enter a while loop, and we ask user to enter URLs if they want to add URLs, or search to actually go into the search mode. And if it's search, then we take in a user query, we embed that query, and then we ask how many results we like to return, and then we call the cosine similarity search. We save those top chunks to top chunks text JSON file, and then we create a messages list. Pretty much, you can also experiment with this, but it says here are some documents that may help you answer the user query. We pass the top chunks, and then we pass the user query. We say if the document don't contain the answers, say you don't know. And then we print the number of tokens in the message by calling the count tokens, but pay attention that I'm stringifying. I'm calling the string. I'm converting these messages list to a string, because that's what count tokens takes in. So then we simply call the GPT call. We don't need to print it separately, since that function automatically prints it with streaming. But if the user has entered URLs, then your user can enter URLs separated by commas. And then pretty much we loop over those URLs, because we're going to split them by the comma. And then fetch the text from those URLs using Gina. We're going to chunk it and extend all chunks. And then save chunks to file, and then get the embeddings for them, extend the embedded chunks, and then save those as well. So that's pretty much it. And then we run the chat loop with async.io.run. I guess the important thing here is that This has pretty much most everything you need really for the most part, scraping URLs, getting actual text out of them. That's what Gina does, especially when you set chunk format specified as text. You can load, regular files, PDF, regular text files or PDF files. You can extend the functionality of the script by adding other functions, for example, for, you know, Microsoft Office documents, something like that. It has functions for counting tokens, token splitting, text splitter, embed text chunks, save chunks to file, and things like that. So I hope you found this useful. Like I said, the code files for this will be available for my patrons. A link will be in the description and also in the pinned comment. Let me know what you think. I want to expand on this and explore some possibilities, but I wanted to share this with you just in case if you want to do the same. Thank you for watching. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x MasterClass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.